Hi friends, welcome back. In the previous session, we have seen Laplace transform. In that Laplace transform, one very important problem. So in that problem, we have solved so many different cases for the ROC. Okay. So from that, we have made some conclusions. Okay. So I haven't given you the conclusions, means in the written form, but I have told you what are the conclusions we have made. So the first conclusion is, if a system is causal, then ROC must be right side to the rightmost pole. That should be the ROC so that it can be the causal system. And another conclusion what I said is, if a system is stable or Fourier transform exists, for both of them we are having the same condition. What is that? ROC should include j omega axis. That is a one conclusion. And one more conclusion point I have seen that, suppose if a system is both causal as well as stable, then what should be the condition? Then the condition is, all the poles must be in the left half of its plane and ROC must be right side to the rightmost pole. If this condition is satisfied, then we can say the system is both causal as well as stable. So I'm just writing those points here. Okay, whatever I said. Let's see the first point, conclusions or observations. Please make a note. Observations. First one, if the system or signal is causal, then ROC must be right side to the rightmost pole. Right side to the rightmost pole. This is the one conclusion point if the system is causal. Okay. So for causal. Next. Second one. If the system is stable, or Fourier transform exists, then ROC must include j omega axis. J omega axis. Next, third point. If the system is both stable and causal, then all the poles must be in left half of its plane and ROC must be right side to the rightmost pole. Rightmost pole. So let's see this third point. Suppose if all the poles on the left half of S plane, so let's say this is a j omega axis, sigma axis, If all the poles here, let's say -1, -2, -3 like that. If I choose the ROC, which is the right side to the rightmost pole here, then you tell me this is going to be causal as well as stable. Why? Because ROC is right side to the rightmost pole, that means it is a causal system, and ROC is including the j omega axis, so it is going to be stable. So I can say this kind of pole pattern and this kind of ROC is going to give you a causal and stable system. Causal and stable. Okay, please make a note. If given x of s is equal to 5 minus s by s square minus s minus 2. If Fourier transform of x of t exist, then x of t is option A. What is x of t? That means inverse Laplace transform they are asking. For that, first try to understand what is x of s. Given x of s is equal to 5 minus s by s square minus s minus 2. That means I can factorize this s minus 2 into s plus 1, s plus 1. This is the factorization I can do. So if I multiply these two factors, I am going to get s square minus s minus 2. Now if I do the partial fractions, here I am going to get 1 by s minus 2 minus 2 by s plus 1. These are the partial fractions I am going to get. Now if I try to find out what is x of t, for this one it may look like the option A is correct, but that is not correct answer. Why sir? Why it is not correct answer? Let's see. They have given one thing, that is Fourier transform of x of t exists. Fourier transform of x of t exists. What do you mean by that? That means they have mentioned ROC. They have mentioned ROC. So what is that ROC? Let's see. Because we are having two poles here, one is 2 and another one is 1. So let's say if I draw the pole 0 pattern, how it look like? Sigma axis, j omega axis. Here is one pole 2, here is one pole minus 1. Now let's see, we are having two real poles. Then how many ROCs are possible? 3 ROCs are possible. One is the right side, one is the left side, one is in between. But out of these 3 ROCs, which ROC we have to select? That is nothing but in between -1 and +2. Why? Because they said Fourier transform is existing. Fourier transform is existing means ROC should contain j omega axis. So that means we have to select ROC in this manner. This is the ROC. This is the ROC because it is given that Fourier transform exists. Fourier transform exists. Fourier transform exists means it must contain j omega axis. That is ROC should contain j omega axis. Should contain j omega axis. So let's see. If I consider this is the ROC, for -1 pole we have to write the right side signal, and for pole 2 we have to write the left side signal. So let's say for pole 2 we have to write the left side signal. So if I take inverse Laplace transform, x of t is equal to, for this one, what is that? Left sided signal. So it is going to be minus e power 2t u of minus t. I told you for left side signal we have to change the sign. Next, it is a right side signal, so no sign change. Minus 2 e power minus t u of t. So this is what the x of t is. So what it is? Answer C. Take it. Question number 3. A stable LTI system having transfer function h of s is equal to 1 by s square plus s minus 6. To make this system causal, another LTI system having transfer function h1 of s to be connected in cascade. Then h1 of s is options s plus 3, s minus 2, s minus 6, s plus 1. These are the options they have given. Okay. So given system is stable system. So they have given this H of S is a stable LTI system. Okay. First try to understand what is H of S. Given H of S is equal to 1 by S square plus S minus 6. 1 by. This is going to be S plus 3 into S minus 2. These are the factors we are having. That means we are having pole 0 pattern which is like this. Sigma axis, J omega axis. Where is the pole? One is at 2, another one is at minus 3. Now let's see. How many ROCs are possible? This one, in between. But they said it is a stable system. Stable system means the ROC should be between the poles. This is the ROC for a stable system. Now try to understand. Here for minus 3 it is a right side signal. For 2 it is a left side signal. For minus 3 pole it is a right side signal. For 2 it is a left side signal. That means if I write the signal or if I write the expression for this pole, it has to be right side signal. That means U of t. If I write the expression for this pole, it has to be left side. That means U of minus t. So I can say in this H of S, this is a right side signal, this is a left side signal, and this system is stable but non-causal. But it is a non-causal. So which is making it is non-causal actually? This pole 2. Why? This pole 2 having a left side signal. I hope understood. So this is a non-causal system because pole 2 having a left side signal. So this is non-causal. H of S is non-causal because pole S is equal to 2 having left side signal, having left sided signal. So I want to remove this left sided signal, then I can get a causal system. That's as simple as that. So if H of S is there, which is 1 by S plus 3 into S minus 2. This is a one system. This is the given system, and we have to cascade another system, which is H1 of S. Then I want to make this total system into causal system. That means what should be the H1 of S? Suppose if H1 of S, if H1 of S is equal to S minus 2, H1 of S is equal to S minus 2. Then S minus 2 get cancelled. Then there is no pole. So we are having only minus 3 pole, which is nothing but right side signal, which is going to give you right side signal, that is going to be causal. So finally, what is overall transfer function? That is 1 by S plus 3 into S minus 2 into S minus 2. So S minus 2 get cancelled. Finally 1 by S plus 3. So this is having definitely a right sided ROC. So the system becomes causal. So we have to multiply with S minus 2. Take it. Next property, time shifting property. Time shifting property. What is this time shifting property? Try to understand. If a signal x of t having Laplace transform x of s with ROC is equal to R, with ROC is equal to R. Then x of t minus t naught. What is the Laplace transform for this? I already told you so many times. Shifting in one domain leads to exponential multiplication in other domain. So here time shifting is there. So in S domain it has to be exponential multiplication. Then x of s e power minus s t naught. But here ROC does not change. ROC is going to be same. In the similar manner, x of t plus t naught. Then this is x of s e power s t naught. ROC is same as R. Let's take one example so that you can understand easily. U of t minus 4. What is the Laplace transform for this? Let's say. First we know u of t, right? Having Laplace transform 1 by s with ROC sigma greater than 0. Then what is u of t minus 4? For u of t minus 4, what is the Laplace transform? This is 1 by s e power minus 4s. But here still the pole is s is equal to 0, so sigma greater than 0. I hope you understood. So it won't change. So in short I can write e power minus 4s by s. Okay, still sigma greater than 0. Take it. Let's take another example. E power 5t u of minus t. For this signal, what is the Laplace transform? Let's see. E power minus 5t u of t. For this, we know that 1 by s plus 5 with sigma greater than minus 5. With sigma greater than minus 5. So I am going in the natural order. So first I am applying the shifting. E power minus 5 t plus 3 u of t plus 3. Because of shifting, I can get e power 3s by s plus 5. Still sigma greater than minus 5. But if you observe carefully, there is an extra term. So what is that extra term? E power minus 5t into 15. So e power minus 15. So that e power minus 15, bring it here, that is going to be e power minus 5t u of t plus 3. Here we are having e power minus 15 extra, so bring it this side. That is going to be e power 15 into e power 3s by s plus 5. It won't change because we are simply multiplying with some constant only. Okay, so it won't make any difference. Now let's see, observe here. So here from this to this, only one change we can observe. If t is replaced with minus t, that's it. We are going to get the answer. Yes. So that is nothing but the time reversal property we are applying. So e power 5t u of minus t plus 3. So in the time reversal property, s has to be replaced with minus s. e power 15 into e power minus 3s by minus s plus 5 plus 5. So I can take this minus into the numerator also, s minus 5 also I can write, otherwise we can keep it like that. Okay, better write it, minus e power 15 e power minus 3s by s minus 5, s minus 5. So that's what we got. Now whenever time shifting property is applied, so r becomes minus r, ROC becomes minus r. What do you mean by minus r? We have to change the inequality, we have to change the sign. That means sigma less than 5. Directly also we can say how. What is the pole here? 5. It is a left side signal. For pole 5, left side signal, sigma has to be less than 5, less than the pole. I hope you understood. Take it. Y of s is equal to e power minus 3s by s plus 1 into s plus 2. Find y of t if, first question, sigma greater than minus 1, second question, sigma less than minus 2. So listen here. If this e power minus 3 factor is not there, then it is 1 by s plus 1, s plus 2. So directly we can go for partial fractions. Then we can calculate y of t based on the given ROC. This is what we can do if there is no e power minus 3s. But there is e power minus 3s. Then what we can do? So better we can assume, let's say, assume let y of s is equal to x of s into e power minus 3s. I can assume like this. Here, where x of s is equal to 1 by s plus 1 into s plus 2. Okay. So if you observe carefully, if I could write like this, x of s does not have the e power minus 3s factor, so directly I can calculate x of t. But we don't have to calculate x of t, we have to calculate y of t. So this is not the answer we require, actually we require y of t. Then we have to understand what is the relation between x of t and y of t. So if you see here, this, if I apply inverse Laplace transform, you tell me, this is y of t is equal to, x of t has to be there, but if it is multiplied with exponential in the time domain, it has to be shifting. So it is y of t minus, x of t minus 3, x of t minus 3. So this is the relation between y of t and x of t. So if I could find out what is x of t, from that we can calculate y of t by simply replacing t with t minus 3. So I am calculating x of t now. So let's see how we can do that. What is x of s? If I do the partial fractions, 1 by s plus 1 minus 1 by s plus 2. These are the partial fractions for x of s. Okay. So how many poles are there? 2 poles are there. One is minus 1, minus 2. So we are having 3 ROCs, but they have given only 2 ROCs. For them we have to calculate. So let's see, first, sigma greater than minus 1. Sigma greater than minus 1 means this is minus 1, minus 2. So this is the ROC. For this ROC, for both the poles, we have to write the right side signal. Then what is x of t? E power minus t minus e power minus 2t u of t. For both the poles, it is right side signal. This is what x of t. Then what is y of t? Which is x of t minus 3. Wherever t is there, that has to be replaced with t minus 3. That is e power minus t minus 3, e power minus 2 t minus 3 u of t minus 3. So this is what the expression. You can still simplify this: e power minus t plus 3 minus e power minus 2t plus 6 u of t minus 3. So that's what the expression if sigma is greater than minus 1. In second case, sigma less than minus 2. Sigma less than minus 2 means this is what? This is the ROC we have to consider. Okay. So you tell me for this, what is x of t? Because it is a left-sided ROC, for both the poles, we have to write the left-sided signal only. So how can we write the left-side signal for this? This is, we have to change the sign, minus e power minus t u of minus t plus e power minus 2t u of minus t. For both the poles, it is a left side signal. So this is what x of t. So from this we can write y of t, which is x of t minus 3. That is minus e power minus of t minus 3 plus e power minus 2 t minus 3 u of minus of t minus 3. So this is what we are going to get: minus t plus 3 plus e power minus 2t plus 6 u of minus t plus 3. So this is what we are going to get. Clear? Take it. Next property, differentiation in time domain. Differentiation in time domain. Okay. If a signal x of t having Laplace transform x of s with ROC R, then dx of t by dt. Yes, x of s. Simply we have to multiply with s. That's what the meaning. Then ROC does not change, which is nothing but R only. Suppose if it is 2 times differentiation, then it is going to be 2 times multiplication with s. This is s square x of s. ROC does not change. So suppose if I differentiate it for n times, then we have to multiply with n times. Still ROC does not change. ROC does not change. Okay. Let's take one example. X of t is equal to e power 2t d square by dt square e power minus t minus 3 u of t minus 3. find x of s. Find x of s. How we can do this? Okay, listen. First, we have to start from what we know. Let's say e power minus t u of t. Start from this point. We know this one. What is that? 1 by s plus a sigma greater than minus a. Sorry, 1 minus 1. Now, time shifting we are applying. So, e power minus t minus 3 u of t minus 3. Then we have to multiply with e power minus 3s s plus 1. Still, ROC does not change. If I differentiate 2 times in the time domain, then in the s domain we have to multiply with s square sigma greater than minus 1. Okay. Now, if it is multiplied with e power 2t, so if I multiply with e power 2t, there we have to shift. That means s has to be replaced with s minus 2. So s minus 2 whole square e power minus 3 into s minus 2. So here if I write s minus 2, then it is going to be s minus 1. Sigma greater than 1. Why it is sigma greater than 1? See, the pole is got change here. S is equal to 1 and it is a right side signal, so sigma greater than 1. So this is the way we can do it. Take it.